Hello friends, welcome to my video. Today I'm going to talk about C# reflection. I'll explain what reflection is and how we can use it in a program. We'll also learn what problem it solves and its uses. Before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way you will be notified every time I upload a new video. Okay, without any further delay, let's get started. What is reflection in C#? Reflection in C# enables us to get metadata of a type at runtime. Metadata contains assemblies, modules, and types. We can also use reflection to dynamically create an instance of a type, bind the type to an existing object, or get the type from an existing object. We can also invoke the types method or access its fields and properties. There is a dedicated namespace for implementing reflection, which is System.Reflection. There is another supporting namespace, which is System.Type. So with the help of these two namespaces, we are able to implement reflection in C#. Okay, let's understand it with the help of example. If you see the example number 1, int I is equal to 5. Type is equal to I dot get type, and then we have written console.writeLine and type, right? So what this example shows us, we have defined int I is equal to 5, right? And then we are finding what is the type information of this int, right? I dot get type. So those information we capture into this type variable and then we have printed, right? And if you see the output, it says system.in32. Basically, I type is system.in32, and that's what it got printed into this output, right? Okay, let's understand it. Reflection with the help of example number 2. Here we are trying to get the information of an assembly of the type int, and that's what we have written System.Reflection.Assembly, and then we have given the instance name info is equal to type of int.assembly. So what this statement is doing, it is just trying to get information of assembly of type int, right? And then we have stored those information into the info instance of the assembly, right? And then we have printed those things into this console window. If you see the output, information of assembly of type int, which is MS Corley version 4.00 culture and public token, right? Public key token. So all these information which was associated with this int assembly, and that's what we have, captured those information and we have printed into this console window, right? And that's what you are able to see the output here. Okay. So important classes of System.Reflection. Here we will be seeing some important classes of the system reflection, right, which is important while implementing reflection. Okay, so if you see the class assembly name, type, method info, parameter info, property info, member info, so these are the classes. If you see the type is not from the System.Reflection, it is system namespace. Okay, it is from the system namespace, but it inherits System.Reflection.Member info class. And it is very much important to know what is the declaration for types, whether it's a class types, an enumeration type, array types, value type, or interface types, right? So if you want to get the type, then we can use this type class, right? Here assembly, it represents an assembly which is reusable, versionable, self-describing building block of a common language runtime application. Assembly name, it's a unique name identifier of an assembly. Method info, with the help of this class, we are able to get class method information and what is the access, and we can get the access of its metadata, right? Parameter info, it discovers the attribute of a parameter and provide access to a parameter. Similarly, property info, it is giving me option to discover the attributes of a property and provide access to property metadata. Similarly, for member info, it help us to get information about the attributes of a member and provide access to the member metadata. So these are the important classes. There are so many classes, but these are the important one, and we have just listed out over here so that you can get an idea what are those classes and what is the purpose of those classes, right? Okay, now we will be seeing the uses of reflection. So what are the uses of reflection? If we want to achieve this late binding to methods and properties, we can use reflection. If you want to accessing attributes using reflection, then we can access it. Creating new types at runtime using System.Reflection.Emit, right? Let's suppose if you want to create classes at the runtime, okay, so that time we can use the reflection, and this namespace System.Reflection.Emit namespace is able to help us to create a new type at runtime. Okay, if you want to examine and instantiate types in an assembly, we can use reflection. If you see what is the use cases of reflection, right? So if you see this IDE, integrated development environment, suppose if you want to create some new integrated development environment, so here reflection can be heavily used for showing these properties and all those things with the help of reflection, right? Like Visual Studio, this is the one of the IDE. Some other IDE which is if you want to develop, then reflection you can be used to use their properties and all those things. And if you remember, whenever you write something into this Visual Studio for class, right? So if you point dot, right, then it will give me what are the properties, what are the method associated with that, right? So basically it's intelligence. So reflection can be heavily used to show the intelligence with all these details in ID, right? So these are the use cases of reflection. For late binding to methods and properties using reflection, it is one of the uses of the reflection. Okay, let's understand it first. What is late binding? Late binding means runtime binding or dynamic binding, because we don't have the knowledge of the class that has to be instantiated at compile time. So we go for the late binding, right? And late binding can be implemented using the reflection. Okay, let's understand it with the help of example. Here there is a class imply that has one method get imply full name that accepts two string parameter, first name and last name, and return first name last name as a full name, and return type is a string over here. Okay, so that is basically one imply class. In main method, what we are going to do, that we are first finding what is the current executing assembly. How we can get it? Assembly.get executing assembly. Okay, assembly.get executing assembly. So it will be giving the reference of the executing assembly, and that's what I have just written, assembly executing. So in this executing instance name, we will be getting the current executing assembly information. Okay, and then we are trying to get the type reflection demo.imply. That is basically this imply is written into this reflection demo namespace. Okay, and there is a class name imply that's we wanted the get the type information. Okay, so I have just using this get type method, so executing that get type reflection demo.imply, and we are stored into this imply type variable. Okay, the next statement what we are trying to do is we are just going to get the reference of this get imply full name, right? And that's what we have used. And we have used imply type dot get method, then we have given get imply full name, so that we can get the information of this method get imply full name, and that's what we have stored into this method info class variable, right? Get method. In the next statement, I have created the instance of the implied type. Okay, because we are going to create an instance. So here there is a new way to create instance. We are not going to use the new operator. Here we are going to use the activator class and its method create instance method. So activator.create instance implied type, that will be giving me object of imply object, right? So we have created this instance of the implied type, and this is imply object. Now I have just created parameter array that accepts two array input, right? Lisa and Ray. Lisa is nothing but the first name, Ray is equal to last name, and that's what we have stored into this parameter array. Okay, in the next statement, what I'm trying to do is I'm trying to invoke this method. So how we can invoke that method? Get method dot invoke. Get method dot invoke, and what we have written, imply object and parameter. Here we are passing imply object, which is nothing but instance of imply type, and the parameter array that we are passing as a parameter to this particular function. Okay, so we have invoked those things and we got the result that we have stored into this string variable, right? A string result, and that's what we have printed into this console window, imply full name colon result, right? And that's what, if you see the output, it got printed into this console window, imply full name Lisa Ray, right? So that is the late binding, because we don't know at the compile time which class we need to instantiate, right? So late binding we are doing over here. So we are using assembly class, its method, we are getting the type, we are getting the method, and then we are creating an instance with the help of activator.create instance method. We are passing parameter, we are passing parameter as a first name, last name, and then at the last we are invoking this method using this invoke function. And then invoke function we are passing two parameters, imply object and parameter array, and whatever the result we are getting, we are storing into this result variable, and then we are printing into this console window. That's what you are able to see the output, imply full name Lisa Ray, right? So that's lead binding to methods and properties. Okay, so here we are on Visual Studio. Here I have written the same program what we have just not discussed. So here we have main method, and we have this imply class, we have this method. Inside that we are accepting two parameters, first name last name, returning that full name, first name and last name. And then here we have captured what is the current executing assembly, and we have created the type of class imply. If you see this reflection demo is nothing but here namespace, and inside that we have this imply. So that's what we have written for getting this type, reflection demo.imply. Then we are capturing the get imply full name information into this method information. Then we are creating this instance of imply type using activator.create instance, passing this imply type that we have get it over here. And then we have created this parameter, and then we pass the value as the first name and last name. And at the last we have invoked this method in this invoke method, and we have passed two parameters, imply object, which is an instance of imply type, is the parameter. Basically we wanted to send that parameter value for that particular function. Okay, so this method got invoked, and then we got the output as stored into this result variable, and then we are printing into this console window. That is the same program that we have discussed earlier. So let me execute this program. We click start with the output. Now the build is started. Okay, now the output got appeared into this console window. If you see, it got printed Lisa Ray as a full name, right? Imply full name Lisa Ray. That is the message that I wanted to show, like reflection demo. A demo that I'm depicting, lead binding to methods using reflection, right? Accessing attributes using reflection. It is one of the uses of reflection. Okay, so here we will be seeing how to access attributes using C# reflection. Okay, let's understand it. What is custom attribute? If you see here, class blogger class 1, right? We have written blogger Ravi version is equal to 1.0. It is conceptually equivalent to blogger, obj blogger is equal to new blogger, where we are passing Ravi in the constructor, and then obj blogger dot version is equal to, right? So this writing is equivalent to this. Now we understand what is the meaning of that, right? What is the attribute is, and how we can treat it, those attribute in terms of programming. So it is equivalent to this way, right? Okay, now let's see example over here how we are going to access attributes. Okay, so if you see here, there is a class blogger that is inheriting system.attribute class. Okay, and we have variable string name, we have variable properties public double version. Then this in this constructor we are accepting a string name, and then we are assigning to private variable a string name is equal to name and version is equal to 1.0. And then there is a method get name that basically return this name. Okay, and if you see this blogger class 1, where we have custom attribute blogger Ravi. If you see the class 2, blogger class 2, we have not assigned any custom attribute to this class. But if you see the next class, blogger class 3, we have assigned multiple blogger attribute. Blogger Ravi, blogger Albert, version 2.0, right? There are two blogger attribute we have, assigned to this blogger class 3, right? So we have seen what is blogger 1, blogger class 1, blogger class 2, and blogger class 3, in which class we have attributed this custom attribute, right? 1 and 3 we are having, 2 is not having any custom attribute attached to it, right? Now I have written one static method, so blogger attribute details, where we are passing type t. Here I just want to, print that message blogger information for which type that we type that we are receiving into this method. Okay, that's we are going to print it into this console window, right? And then using reflection, I'm just going to get the custom attribute. So how we can get it? System.attribute.get custom attribute. So get custom attribute, that is a method where it accepts the type and give the attribute details, right? And those attributes information we are storing this attribute array. And then for each loop we are iterating one by one this attribute array. And then if attribute is blogger, then we are creating this blogger instance, and then we are calling blogger.getName and then version blogger.version. We have printing into this console window. Okay, so that basically so blogger attribute does. So here we are just calling so blogger attribute details, where type of blogger class 1, type of blogger class 2, type of blogger class 3. So 3 times I have called this method, a static method, and we have passed in first time we are passing blogger class 1 of type, right? Blogger class 2, blogger class 3. And if you see the output, blogger information for reflection demo dot blogger class 1, it is just giving me information of these custom attributes. The first is Ravi and then version is equal to 1.0, right? Blogger information for reflection demo dot blogger class 2, there is no custom information because there is no blogger attribute attached to this blogger class. That's what there is no information. If you see this blogger class 3, we have information Ravi version 1.0, Albert version 2.0. If you notice over here, I have just given here blogger name, right? Blogger, so Ravi, but here in Albert case we have given the version detail 2.0. That's what 2.0. If you notice here in this blogger class, default value is version 1.0. That's what it got captured for this Ravi, where we are not passing this version detail. It got captured version 1.0, and that's what it got printed into this console window output, right? So that's the way how we are going to access attributes using C# reflection. Okay, let's execute this in Visual Studio and see the output. So here we are on Visual Studio. So I have written the same program over here. So if you notice, we have this blogger class and we have used system.attribute users, where we have attribute targets is class or abstract and the allow multiple is equal to true. So we have defined custom attribute. And if you see here, this is the blogger class where we are implementing, where we inheriting the system.attribute, where we have two properties, name and version, right? And in this blogger constructor, we are accepting a string name. We are assigning those values to this name property, and then version is equal to 1.0. We are setting as a default, and there is a method get name that basically return this name. And we have three class: blogger class 1, blogger class 2, blogger class 3. Blogger class 1 and blogger class 2 have this custom attribute attached to it, like blogger Ravi. Here blogger Ravi and blogger Albert version 2.0. So here I have defined attributes, I mean the multiple blogger attribute associated to this blogger class 3, right? And in this, and there is a method show blogger attribute details, that is a static method that accepts type E as an input parameter, and then we are printing blogger information for this type that we have received for this particular method. And then using reflection, we are getting the custom attributes detail. right? System.attribute.get custom attribute. Then we are storing into this attribute array, and then we are iterating with the help of for each for each system.attribute attr in attributes. And then if attribute is blogger, then we are instantiating this blogger class. Okay, and then we are calling get name, and then we are using properties version for printing those things into this console window, right? So that's the program. Now let me execute this program over here. Just click the start button. Okay, now the output got appear into this console window. So you are able to see this output, right? Reflection demo accessing attributes using reflection. So blogger information for reflection demo.blogger class 1, where we have printed Ravi and version 1.0. Version 1.0 was the default one, and we have passed this attribute Ravi, and that's what it got printed over here. Blogger class 2 was not associated with any custom attribute, so that's why there is no information. But blogger class 3 is having two properties, two attributes, blogger attribute attached, one for Ravi and one for Albert. Albert and version 2.0 that we have passed as a value, that's what it got printed. Ravi we have passed, and version 1.0 it is coming from the default value. And that's what we have accessed all those attributes using the reflection, creating new types at runtime using System.Reflection.Emit. That is another uses of reflection. So here I wanted to create a new type at runtime using System.Reflection.Emit, right? If you see left hand side, here I have written class my runtime type. It has variable private int num, public my runtime type int number, which is nothing but a constructor that accepts int parameter and it assigned to the private variable, right? This num is equal to number. And then it has one method multiply that accepts int multiplier, right? Then it is just multiplying with the num into multiplier and give the result of the int data type, right? So that is the class that I want to create. I mean the similar structure I want to create with the help of reflection at runtime. How we can create it? So there are a couple of steps that we need to follow, right? So these are the steps I have written over here. Steps for creating new types at runtime. How we can create assembly and give it a name. That is the first step. Create module same as assembly name. Second step. Third step is create type, that is the class my runtime type. That is the third step. Then add private field using the define field method. Define a constructor using the define constructor method that takes an argument and store it into the private field, right? Then we need to define a multiply method using this define method of type builder class. And finally, finish the type creation using the create type method. So these are the steps we need to follow for creating a new types at runtime. So once the type is created in client code, we need to call get method for method info, so that once we get the method information, we can create an instance using this activator.create instance method, and then invoke the method using the invoke method of the method info class, right? So we can see all those things in Visual Studio. Let's switch to the Visual Studio and see in action. Here we are on Visual Studio. I have created one console application that has one class reflection emit. In this main method, which is nothing but an entry point of this particular application, I have written assembly name a name is equal to new assembly name, and we have passed this dynamic assembly demo as a name of this assembly, right? So that it will be unique identified. Now assembly builder class we are using, and its method defined as dynamic assembly. We are calling this method, we are passing assembly name, and then we are giving the access for execution assembly builder access.run. Then we have created this module. So for that we have used define dynamic module method where we pass this a name, right? Then we are defining type. So for that we are using type builder class, and we are using mb.define type. So my runtime type is nothing but a class name, and then its access modifier is public. That's what I have written, type attributes.public. Then we are adding private field of type int. So Field builder fb number is equal to tb dot define field num type of int field attributes is a private, because that properties that I'm going to create, it is int data type, and the access modifier to that particular property, it should be private. That's what, field attribute dot private I am mentioned over here. Now we need to create a constructor that takes an integer argument that stores into the private field. For that, we have given this parameter types. Parameter, basically that constructor is going to receive int. That's what I have written, type of int. That is the parameter types that we have accept into this type array. Then constructor builder class we are using, and tb.define constructor method we are using, and we are passing method attribute public, calling convention.standard, and parameter types. And this is the parameter type that I have created, that is nothing but collection of integer. But here we are just passing one parameter, so one parameter should be passed under this parameter types. Then we are using il generator ctor il generator. For a constructor, argument 0 is a reference to the new instance, so we need to push it into the stack before calling the base class constructor. So that's what we have specified the default constructor of the base class by passing an empty array of the types to the get constructor. So that's what I have written, ctorl i.emit opcodes.ldrg. That is the way basically we need to pass those things into the stack. So emit call type of object, get constructor type, emit types, push the instance on the stack before pushing the argument that is to be assigned to the private field now. So that's what ldec 0, ldec 1, and then here we are passing the fb number that we have created here, right, which is nothing but a private field. So we are associating, I mean, that the constructor that receiving the value from the client class, that is accepting that value, and we are assigning to the private variable. That's what I have given the instruction to the constructor section, so that it can be assigned to this private variable, whatever the value that we are going to receive. Okay, and then we are writing emit opcode.read. Basically these are the standard codes we need to follow. Okay, now we have to create define constructor method public standard empty types, then get il0 ldc45. Here what we are doing, here we are assigning the value of that particular constructor. Okay, so int basically nothing but it's a 5 variable. We are just assigning those things so that it will be stored into the num private field, right? And then we have defined this method multiply, which is a public access modifier associated to this multiply method, and it accepts type of int, I mean the integer data type variable value it is going to get a step, and this is the new type of int. Basically it is going to get that value. Type of int nothing but is a return value, and this is the input parameter that this method is going to receive. Then we need to write il generator meth il is equal to mh get il generator. It is nothing but a to retrieve the private instance field, load the instance it belongs to the argument 0. After loading the field, load the argument 1 and then multiply. Then return from the method with the return value on the execution task. That's what I have written these things, right? And then at the last we need to finishing by creating a type. That's what I have written, tb.create type, so that type gets stored into the t. Once the type gets created, then we need to get of that assembly that particular method. So for that, with the help of this type, we are going to get method that we are going to use, and we are passing multiply, so that multiply method information that we wanted to get it, and that we are receiving by this calling this get method, right? And then we are storing into this method info class mi as an instance, and then we are going to create the class object. How we are going to create? For that we need to use this activator.create instance, and then we need to pass the type, right? So that once we receive, then we have this argument, okay, that we have created over here argument 10, and then we are going to call this multiply method with the help of this class, right? Class object. So O01 dot multiply 10, and then we are going to print this value, right? For that we have invoke this method, my invoke O1 and arguments. O1 is nothing but our class, right? And arguments is nothing but our input parameters that we are sending to particular method. In that case, multiply method. Then we are invoking using this mi.invoke. Once we get the output, we are writing into this console.write line into the console window, and then we are reading those things. So this is the program we have written. Basically, this program give the instruction to the compiler to create a class at runtime, and once the class is created, we are accessing class attributes methods, and then we are calling that method after passing some parameters. Let's see what is the output is coming. Let me execute this start button. Now if you see, the output got appear into this console window. 01 dot multiply 10 and 50, because if you remember that constructor level we are passing 5, the 5 value, and an argument for this particular method we are passing 10 as a value, and 10 into 5 we are multiplying and returning the output as a 50. That's what it got printed into this console window. Okay, that brings me to end of my session. To sum up, in this video we have learned what is reflection in C# and its associated common classes. Then we saw usage of reflections and its use cases. We saw with example how we can achieve late binding, how to access attributes using reflection, and then finally we witnessed how we can create new type using System.Reflection.Emit. Okay, if you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thank you. See you next video.